Exercise A02 is going to have us implement our first function in the framework we define in exercise A01. So the function will be a least common multiple, taking two parameters a and b of type integer, positive integer, we're going to enforce that, and returning the LCM of those two numbers. So we are going to add the prototype in tools.h, we are going to add the implementation of this function in tools.c, then we're going to use it from the main function respectively located in main.c, where we're going to invoke it from the menu on the current value of x and y, and test.c, where we're just going to call it to implement pretty much our test harness. As you can see here, when you pass the wrong type of parameters to this function, like negative integers, for example, it will react by returning the value -1, which is going to be in our application the sign that I could not do my job. You have here a couple of examples of what the function should return. This is not showing you what should happen on the screen, so we have degrees of freedom here as far as how we're going to organize our calls from main.c, for example. Okay, so let's start by actually tools.h, and we're going to define the prototype. Actually, I should have it here. We're going to define the prototype of this function. Okay, int LCM takes two parameters, int a, int b. And once we have the prototype, we're going to save this. We're going to go to tools.c, and we're going to throw in the implementation of this function, the definition of this function. Okay, so we have something right now that doesn't do much, and in fact I'm going to say here return, let's say 0. So we have an empty function that doesn't do much. Let's try to compile, and then we're going to try to use it from main.c interactively before we move forward. So first I should exit my previous test here. Let me see. Tools.c, main.c. No compilation error. Let's try to, well, there's no real point in running it before we modify main.c, so let's go to main.c. Computing the LCM is choice number 2, so right here we are going to compute the LCM of the current value of x and y. So we are going to display the result of calling this function. So LCM, and I'm going to display here %d for x, let's make that a little more readable, %d for x and y, and then %d for the result. And this is all I'm going to display. So x, y, and then I call LCM x and y. So LCM x, y will return a value, right, which is going to be used as the third %d in our printf. And once I'm done doing that, break, save. Now we can recompile and we can actually test something. So compile first, hit on out. X and y is 0. So no matter what the value of x and y are, right now our function returns only 0. So let's just test if it's called properly and if it returns something. Choice 2, LCM 0 and 0 is equal to 0. Okay, so far so good. Let's exit the application. And let's go back to our code. So we have the call from main.c. The only thing we don't do in main.c is trying to detect actually if there was a problem calling as LCM or not. So let me add here a little variable, int result. I'm not going to initialize it. And I'm going to here call LCM, store the return value in result. And instead of displaying the result of the call directly, I'll display the variable result. Well, what this is going to allow me to do is to test if my result was -1. If my result is -1, then there was a problem. Printf, LCM, and I'm going to use the same format, okay, %d equal, and I'm going to display error, between parentheses, parameters, and fit. There we go. And I'm going to have after that x, y, and I will be done. So let me try to fit this. Okay, instead of saying parameter and fit, I'm just going to just put errors just so that it fits on the screen. You are more than welcome to try to do something a little bit more accurate there. So if result equal -1, I display there was an error calling LCM, else I display the result of calling LCM. And this is a pattern we're going to use for case 3 and 4 as well, of course. So let's give it a quick compile. Compiles right. And now let's test to see if we detect indeed error cases. Return -1. I erased the wrong stuff. Save. So we don't do any job yet. We just return error situation every time. Let's see how this is handled by the program. A.out. I want to compute the LCM of those two values. LCM of 0, 0 equal error. Okay, so we know that we detect in the main.c when there was an error, we display an appropriate message. Otherwise, we display the result of calling the function. Now we need to go back to the implementation of this function and actually do the job that is required of us. So how are we going to tackle this this LCM? Well, the least common multiple is the first number, let's call it n, which is going to be divided by a and b. So pretty much what we can do here, we can start with a value of n equal to 1, and we're going to keep progressively increasing n until n can be divided by a and b exactly. So that means n modulo a is going to be 0, and modulo b is going to be 0. So let's get started with this loop here. For n equal 1, I could skip this initialization, but for n equal 1, I'm going to skip my condition for now, n++. So right now I have an infinite loop, right? And what I'm going to do here is if n modulo a equals 0 and n modulo b equals 0, if both of those are true, I'm going to simply return n. So I'm getting out of the loop, I'm getting out of the function here. The return -1 here needs to be taken care of. So I'm going to move it up here. When do I need to return -1? When one of my parameters is not suitable. So if a lesser than 0 or b lesser than 0, okay, oops, it's supposed to be a parenthesis here, b lesser than 0. If either of those is true, then I have a problem because I will not operate on 1 or 2 negative parameters. So if one of the other is true, I return -1. Otherwise, I go in the loop here and I start counting at 1. I keep increasing n until I found a value for n which allows n to be divided exactly by a and b, in which case I return the value of n. There are multiple ways you can write this, and if you have still problem with loops, etc., I really recommend that you try to write this with a for loop, with a while loop. If you try to move here the condition inside of the for, so you'll have to modify it a little, etc. Okay, let's save this and see how bad it is. Let me go back to Conqueror. We're going to start by compiling. Execute. So this is how we are going to test. We need to test with a list of value of for x and y. So we have an option here that allows us to set new values for x and y. Let's go back to the description of our assignment. Well, we have a couple of values here that I'm going to write down as soon as I can find a little piece of paper here. So we have a couple of values that we can test. 10, 20 should return 20. 3, 9 should return 9. 5, 9 should return 45. -1, 3 should return -1. And you can tell already that concerning the error, we might want test also 3, -1, and -9, -30, for example. So testing the first number being negative, the second being negative, and both of them being negative. Of course, because we wrote the code, it looks to us that this is, unnecessary, but it's actually a part of testing thoroughly a piece of code. So I have these numbers, this value jotted down on a piece of paper right now, and we are going to play with the application to test those possibility. So x is 10, y is 20. Let's compute the LCM. The LCM is 20. Okay, let's change the value of x and y. What about 3 and 9? Compute the LCM. The LCM is 9. So far, so good. What about 5 and 9? LCM is 45. Still good. What about changing the value now to -1, 3, and then trying to compute the LCM? Error. Okay, that's good. What about 3 and -1? Try to compute the LCM. Error. What about -9 and -30? Try to compute the LCM. Error. So right now, I can write down those test value. We had 10, 20. Expected was 20. Observed was 20. Then we had 3, 9. Expected was 9. Observed was 9. Then we had 5, 9. Expected 45. Observed 45. Then we had -1, 3. Observed was error. Expected, sorry, was error. Observed was error. Then let's go for 3 -1. Same thing. And then -9 -30. And same thing. Okay, so we have here our minimal test harness. I think this should be enough to cover enough cases so that we are sure our program is working. We have covered regular functionment situation. We have covered error situation. And now what do we have to do? Well, we know that our program is working now with the interactive menu. So I'm going to go back here, stop the application. We know it's working with the interactive menu. Now what we have to do is to complete the test.c code so that all those test harnesses that we played with are now implemented and we can run them automatically. So how are we going to do that? Well, we are going to call the LCM function repetitively, and we are going to check its results. And if a result is not conform to what we expect, then we are going to display an error message on the screen. So let's start with the first test we made. So I'm referring here back to our test harness, right? If we did the LCM on 10 and 20. If 20 equal LCM 10, 20. Here's a side question, by the way, while we're at it. You will see often people write things like that, 20 equal x in an if statement, instead of if x equal 20. So every time you have a value and a variable, you will see people reverse actually the order of the value of the variable. Try to take 10 minutes to think about why this is so, and if you're not sure or you cannot figure it out for yourself, pose the question on the forum, and we will discuss this programming practice and what benefits it can have. Okay, in this case, I just chose to do it this way, but it's not something that I would have to do. 20 equal LCM 1020. Well, if this is equal, I don't have an issue. So my test is successful. So I'm going to test instead if the return value is different than 20, in which case I'm going to display error LCM %d different than %d. So I'm giving some information to allow for the debugging of this error. Okay, so the values are, let's try to put that with variables, and different than result. I'm going to use only variables here so that I will be able to cut and paste this line over and over as I do multiple tests. So I'm going to assume that I have int x, y, result available, and I'm going to say x is, in my case it was 10, y equal 20, and the expected result is equal, oops, to move this cursor out of the way, expected result is 20. And then the line that calls and checks if the result is what is expected is going to be always the same, no matter what are those values. So here we go, let's indent that a very readable way here. There we go. This is a code segment that is going to make one test for me. Okay, and you could have come with different solution, of course. I'm going to move forward, and I'm going to do the next test. The next test was 3. Value of x is 3, 9, and the result was, the expected result was 9. So once again, I'm going to compare it to my expected result, compare the actual call to the expected result, and well, depending on how much I get, I am going to display nothing, which means the test was successful, or I'm going to display an error message. Let's move on and keep doing this. This time I'm going to use, what is my first one? 3, 9 I just did, so 5, 9, and the result should be 45. We keep going like this. Minus 1, 3, and then the result should be minus 1. Minus 1 means there was an error. So if my function detects successfully that there was a problem, then I'm done with the job, okay? Should have used that one here. Let's be lazy. Minus 1, 3, 3 minus 1. 3 minus 1, and I realized that I forgot the semicolon here. I'm trying 3 and minus 1. Once again, the function should detect that there was a problem. And the last one is going to be minus 9. Minus 9 minus 30. Once again, the function should detect that there was a problem. So if we run all of this and nothing happened on the screen, well, we're happy, because that means that no error was detected in our code. Okay? And what am I doing here? I'm trying to increment, to indent it correctly, but I'm doing a very bad job at it. Let's just, well, never mind, forget it, doesn't matter. So I'm going to just save the file, and we're going to go to Conqueror, and this time we're going to compile tools.c, our function, with test.c. And the executable that we generated is going to do nothing, which is good. Okay, now just to make sure, let's go back to tools.c, and let's write a function which returns always 42. Okay, easy modification, it will be easy to revert it back. I'm saving, I'm going to go back to Conqueror and test this, just to make sure that actually my test case are doing something. I run a.out, and there we go. It tells us immediately, well, your function returns something different than 20, different than 9, different than 45, different than minus 1, minus 1, minus 1. One thing that could help here is actually to display also the return value that was returned by LCM. So we can go back real quick to the test.c, there we go. And we can here add real quick equal the value that was returned, which is different than the value that was expected. How do I get the value that was returned? LCM x, y. It's really not efficient because I'm calling the function twice, but that is not a big deal here. Okay, and I'm going to replace all of those if statement by this code, this updated code. So there are ways to make that a little bit more efficient, like I already suggested. There is probably a way also to make the code a little cleaner, especially when we start using arrays and stuff like that. For now, we are just going to work with this first approach. I want you to understand the methodology first, and then we'll work progressively on optimizing, on improving the way that we perform those tests. Okay, so just so that you know, when you are programming in real-world situation, you do not do your tests on S like that. You actually have testing suites like JUnit in Java that are going to allow you to do this much more easily and much more in a much more clean manner. Let's recompile and let's run. And this time we get a little bit more information. We could add a little bit of tabbing there to make it like easier to read, but this is something I'm going to leave you do as an exercise. But pretty much here we are done with this code. So let's go back to tools.c, which is the most important code, and we are done with this exercise as soon as I remove this little testing thing that we did here. There we go.